Hello, this is our third video of F1, and it talks about verifying that a triangle is a right triangle and finding the area given 3 points. They also wanted us to plot it, so I went ahead and plotted it before I started the video. But A is negative 5, 3, so that's out there in the second quadrant. B is 6, 0, so it's a quadrantal point on the x-axis, and the other point is 5, 5. So this is the 3 points on the Cartesian plane. And we're trying to verify that it's a right triangle. There's a couple ways to do this, but we're going to do it by the technique that they want us to do in this section. And you can also do it by slopes, but slopes hasn't been introduced yet. So there's an actually easier way to do this a little later. But once we verify that it's a right triangle, we're also going to find the area of that triangle. And hopefully we all know the area by how do you find the area of a triangle. And if you don't, that's okay. We'll cover it in a second. And but that's 31. And then the last two problems, 37 and 44, on this part of this section, we're going to find the midpoint of the segment joining these 2 points. So again, these are 2 points on the Cartesian plane. The midpoint, remember, is the middle point. It's the average of them, and we want to do it for these 2 problems here. Okay. And this is our 3 of 4 videos for this particular section. All right. So what we're going to do to verify that this is a right triangle is that we're going to find the distance between A to B. Then we're going to find the distance between B to C. And we're going to find the distance between A to C. So in other words, we're going to find the distance of all 3 sides. And then we're going to use the Pythagorean theorem and then put those numbers in to the Pythagorean theorem. And the Pythagorean theorem has to be satisfied. And so it's a little bit of work, but the good thing is we don't have to worry about simplifying right now. So we can just get to the square root part, like we did a while ago in the previous one. We had square root of 45, and we had to break it down to 3 square root of 5. Now we can just leave it as the square root of 45. We don't have to simplify it because we're verifying something, not leaving something in a certain form. So anyway, so we're going to find the distance, and we're going to find the distance between A to B. That's why I'm doing a little subscript there. It's A to B. And so it's going to be equals to the square root of, well, A to B is these 2 points. So it's the difference of the x coordinates. So negative 5 minus 6 squared plus 3 minus 0 squared. And remember, the order that you do them does not matter, but you can't forget the squares. You can't forget that's a plus between them. So this is going to be the square root of negative 5 minus 6 is a negative 11. So they're 11 units apart, is what that's basically saying. 11 squared is 121. And then 3 take away 0 squared, that's going to be 9. So that's going to be the square root of 130. Now remember the square root of 45, we were kind of concerned about how that we need to break it down to 3 square root of 5. Square root of 130 might very well have a perfect square in it as well, but I don't want to have to simplify that. Don't need to. So now I'm going to find the distance between B to C. Well, the distance between B to C is the last 2 points, so it's going to be the square root of 6 take away 5 squared plus 0 take away 5 squared. So 6 take away to 5 is subtract these coordinates, and 0 take away 5 is subtracting these 2 coordinates. And do the math on that. So 6 minus 5 is 1, square it. And then 0 minus 5 is negative 5, and then square that. I think it turns out to be like the square root of 26. Because negative 5 squared is 25, and 1 squared, of course, is 1. So it's the square root of 26. And then we find the distance between A to C. So it's the square root of, well, A to C. It's negative 5 minus 5 squared. Let's do my radical. Plus 3 take away 5 squared. So negative 5 minus 5 is negative 10. So those abscisses are 10 units apart. 10 squared is 100. Plus, negative 3 take away 5 is negative 2. So those two ordinates are 2 units apart. So 2 squared is 4. So that's the square root of 104. Now, if you remember the Pythagorean theorem, c squared equals a squared plus b squared, but c is the hypotenuse. And you're like, well, it looks like AB is the hypotenuse and the right angle is like here. You can't really go by that though, and I'll tell you why, because sometimes if you're like I am, I'm a very bad artist, and so you don't know if what looks like the hypotenuse is the hypotenuse. So this is how you figure it out. Look at the three that you found. The hypotenuse has to be the one that's the largest one. And square root of 130 is bigger than the square root of 26 or the square root of 104. So it has to be c squared equals a squared plus b squared. So in this case, c has to be the square root of 130 because it's longer than the other two. So it's going to be the square root of 130 squared equals, and what about the other two, a and b? It doesn't really matter. You can make the other two are just legs anyway, so whichever you want is fine. So it's the square root of 26, that's a. I'm going to let that one be a. And the b is going to be the square root of 104. But if you do the math, the squares eliminate the square roots. They cancel each other out, in other words. So you've got 130 right here, you have 26 right there, and you have 104 there because the squares and square roots canceled out. And if you notice, 26 plus 104 is indeed 130. So the left side equals the right side, so the Pythagorean theorem is satisfied. So therefore we have a right triangle. So this square root of 130 is indeed the hypotenuse. So the right angle would have to be on the other side. And that's important. This is where the right angle is at. Yeah, why is that important? It's important because you've got to find the area of this. And the area of a triangle, remember, if you don't remember, it's 1/2 base times the height. And the base and the height are neither one the hypotenuse. So the base and the height are the two sides that are not the hypotenuse. So, well, which one do you have let to be the base? It doesn't matter. You can shift it around and rotate it around such that the square root of 26 is the base. Or if you turn around far enough, the other leg will be on the bottom. A lot of people think the base is the one on the bottom. It doesn't have to be that way because the base is definitely not this hypotenuse. It's the one that's closest to the bottom of the triangle. So the base is one of the two sides. The height is the other. So it's the ones that are not the hypotenuse. That's the easiest way I can remember it. So it's 1/2 the base, so it's going to be 1/2 times the square root of 26 times the square root of 104. And now on this one, well, it's going to be 1/2 times the square root of 26. Square root of 26 cannot be broken down. It does not have a perfect square root. Square root of 104 can't. It's like square root of 4 times the square root of 26. And actually, nice things really happen right here. The square root of 4 is 2. So this is a little bit of math, mental math. Square root of 4 is 2. 1/2 times 2. So this one's 2 will cancel with the 1/2. And the square root of 26 times the square root of 26. Well, square root of 26 times the square root of 26 is the square root of 576. And you're like, how do you know that? I have perfect squares memorized up into the 30s. So 26 squared is 576. And the square root of 576 is back to 26. You're like, well, I don't know that. I would have to plug it in. Yeah, you could plug it into the calculator, but there's an easier way. Square root of 26 times the square root of 26 is the square root of 26 squared. And like I said, the square root and the square cancels anyway. So square root of 26 times the square root of 26 is just simply 26. So what that means is there are 26 square units inside that triangle. This is a right triangle. But there was a lot of stuff going on here. You had to first verify that it was a right triangle before you could even apply that formula. So we verified it by finding the distance of all the sides, put those into the Pythagorean theorem, and then make sure the Pythagorean theorem holds. So, but like I said, in the next sections coming up, we'll be able to prove that this is a right triangle based on the slopes of these two lines right here. and they're going to be perpendicular. And that comes a little later, and so we had to do a little bit more work because we don't know that next thing yet. But anyway, so that's number 31. The next two problems is just simple midpoints. This won't take us very long at all. It's just the average of the x coordinates and the average of the y coordinates. So the midpoint, capital M, is -3 plus 6 divided by 2. You add up the abscisses and divide by 2, and then add up the ordinance, 2 plus 0 divided by 2. So the point in the middle is 3/2, comma 1. -3 plus 6 is 3, divided by 2 is 3 over 2. Would you accept 1.5? Sure. I'm not big on that. 3/2, 1.5, knock yourself out. It doesn't matter to me. And then 2 plus 0 is 2, divided by 2 is 1. So, and then the next one is add up the abscisses. Abscisses is a plus 0, divided by 2. And then do the same thing with the ordinance. Happens to be the same expression. And so it's going to be a over 2, comma a over 2. A plus 0 is a. There's no, what quadrant is this in? I don't know. I don't know which quadrant AA is in. It's either in the first or the third, because AA could be 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. But those points are in the first quadrant. But on the other hand, it could be -1, -1, -2, -2, as long as the two coordinates are the same. So it could be in the first or third quadrant. So the location of this is dependent on where the AA is going to be in the first place. And the other point is the origin. So, but a over 2, comma a over 2 is the point that's in the middle of those 2 points. And another way you could write it, and I don't know why you would want to, but some people just want to show their smartness, and so they'll write it this way, and then they'll ask me, well, is this okay? And I said, see, I don't have to do this. Again, you're going to, once you get to know me, you're going to know that format like this is irrelevant, and I'll keep telling you that too. So if you write it as a over 2, comma a over 2, 1/2 a, 1/2 a, it's all good. So, but anyway, that's how you find the midpoints. So midpoints are easy, and people mess up the distance formula. Do they ever mess up the midpoint formula? Not usually. The only time people mess up the midpoint formula is they'll put a minus instead of a plus, and the reason they're doing that is because they're remembering that it's x1 minus x2 over here. But if you remember, the midpoint is x1 plus x2 divided by 2. So when they put minus here, it's because they're getting it confused with the distance formula. So I'm giving you some things that people mess up that you might not think about until you get on the test, and then you do it and you make the same mistake. And then I'm giving next semester's people the mistakes that you guys made. So don't be one of those. So, but anyway, so these are the 3 problems from this third video, and we have one more video from this section. So thanks for watching.